if we have y equals x squared and our x is -2, that means we're going to do the value of -2 squared. Now that just means we multiply -2 times -2, because however many of the power you have, that's how many times you multiply that same thing. So what is -2 times -2?
+4.
+4, exactly. So we're going to fill in our chart with 4. And then what about for -1? It's 1. And 0, what about that?
0.
0, because 0 times 0 is just 0. That one's a little bit tricky. It tried to trick us, but we were smarter than it. What about for 1?
Yes, still 1.
Still 1, because 1 times itself is always 1. And for 2?
It's
4. Perfect. So now before we go on to the next table, let's just look at the difference. On that first one, all of our x values, we have negative and positive values, and we also have 0. And our y values for that first function, we had both negative and positive values, right? But what's different about this x squared one?
They're all positive.
They're all positive. That's correct. So it doesn't matter if you put in a negative value because it'll still come out positive. Which makes sense over here, right? On our graph that we made before, because we see that no matter what, it always is going up. It's on the positive side of the graph. Meanwhile, down here would be negative, and there are never any values down here. So why don't you guys try that y equals x cubed by yourselves and fill it out. Let's see what happens with that one. So to just remind you, how are you gonna go about doing that first one? So like, can someone talk me through how to do that -2 cubed?
Isn't it -2 times -2 times -2?
Exactly. -2 times -2 times -2. And if you didn't want to do that all at once, like if you weren't sure what was going to happen, we could break it down into both parts, right? So first we could just multiply this -2 by -2. And we remember up here that we got 4, right?
Yeah.
So we replace that with just a 4. So now it's 4 times -2. And what is that? -8. Perfect. So then just take another second to fill out that rest of your chart. See what happens. Oh, very nice. Very nicely put. Very nice. Great job, Thomas. So, can someone tell me about what they noticed about this one when it's x cubed? Sure, Tori, you raised your hand first.
So I noticed that like when there was a negative number, when you were multiplying it, it went to a positive, and then since you were multiplying again, it went back to a negative.
That's very true. That's a great thing to know. So just like our y equals x, it seems like it's still going to have negative values, right? Well, that's really interesting how it turned positive, but then it went back to negative. That's kind of cool. Is there anything else we notice about it? About just the integer values for y?
Some are negative and some are positive.
What about the values themselves, the numbers? They seem
to get larger in magnitude as you get farther from the origin.
Exactly, magnitude. So magnitude, in case you don't know, that means the absolute value of it. That's just the distance from 0 itself. It doesn't matter if it's negative or positive, it's just the distance. So the magnitudes are getting much bigger, and they seem to be getting bigger much faster than our x squared ones, right? And we also notice the absolute values of these, or the magnitudes, are the same, mirroring it, right? So for -1 and 1, the y values are 1 and -1. And for 2's, we have an 8 and -8. So it seems like they're kind of the same distance, but one's positive and one's negative. And the negatives are the ones that are staying negative y values, right? It's not flipping. So what else can we say? What about for the even values? Did we notice anything with those y values? For x squared, sorry.
For x squared? Aren't they all Some are negative and some are positive.
Not for the x squared. All of them are positive, but it seems to be mirroring it, right? So even on our graph, we see if they're the same distance on the x value on the x-axis gives us the same y value.
So you're suggesting like symmetry?
Symmetry, exactly, or mirroring image.
Yeah.
Let's see what happens when we have negatives of all these functions. So when we have y is equal to negative x, our negative 2 becomes what?
2.
2. And perfect. Sorry, would you like to read yours aloud?
Sure.
You wrote it pretty quick.
For the negative 2, I got y equals 2 because the negative becomes a positive because negative times a negative is positive.
Perfect.
And then for negative 1, I got positive 1. 0 is still 0. For 1, I got negative 1. And for 2, I got negative 2.
Perfect. So it seems like something happened with this one that was a bit different. What happened with these negatives now?
With the negatives, didn't they, unlike the first one where on the top where they were negative before it became positive, it's the opposite when you have the different values.
Exactly, it's the opposite. So that makes me kind of think that when we're going to go to graph this, it's going to be the opposite, right? So let's see what happens with our y is equal to negative x squared. So just to remind you, it's not a negative value squared. We're going to negative whatever value we got for x squared. Oh, wow. That's interesting, right? They seem to have the same values there. But those are all different, except for 0. 0 though is a special case, right?
Yeah.
Yeah. Nice. What happened on this one now?
They're all negative.
They're all negative. That's weird, right? So what do we think this one, it was always positive, right? So what would you think would happen if it was always negative?
It would go down.
It would go down and be like a frowny face. A little bit? Yeah, definitely. And then why don't we just work on the third one? Because then I think we're going to figure out a pattern for all of these that we'll be able to fill out. So now, what happened with this one? Did it mimic anything else that we saw on that line of the negatives?
It just flipped the sign of the actual y values.
Exactly. It flipped it again. That's pretty cool. So now let's see what that actually does to our end behavior, or values of the functions. So for this first one, we drew that already. It goes from negative to positive, right?
Yes.
So let's think about though when we have down there y equals negative x. What's happening to that graph?
It goes positive to negative.
It goes positive to negative. So that means it's actually going to look something like this. Right?
Yeah.
Positive values and then to negative values. And just to show you, would you like to see the positive y equals x cubed or negative y equals x cubed?
I believe we could see the negative one.
The negative. So, Dory, why don't you tell me what values of them are, what they start with for the x cubed, negative x cubed?
This one?
This one.
Oh. Positive.
Positive until they get to they get to negative. So it kind of looks the same, right? But this time it's curved just a little bit. But that's okay, because the important thing to note is that it's starting up and then ending down. So meanwhile, when we said earlier, they start up and end up, and then we said it was going to look like a frowny face. So it'll be something like this. So they both start down and end down. So we're going to flip to our next paper, and we're going to fill out this chart that we've made. So it has, if it's an even function, an odd function, positive or negative. And we're all going to fold them actually this way, just because I think it's a little easier to draw the end behavior on them. So when it's even and positive, it's going to be both up, right? So we can all put our arms up. It's a great way to always check. So they both start up and it ends up. So we're going to just draw 2 arrows like this. It's going to be up and an up. It doesn't matter what happens in the middle, because it's still going to be up. Because it could dip up and down, but in general, or always, when it's an even and positive, it's going to be like this. Who wants to tell me what's going to happen when it's even and negative?
They'll both go down.
They'll both go down. So we'll draw something like this. And if we put our arms, they will both be like this, right? Ends in that way. So now let's try for positive and odd. That was that first function we even drew. Isn't that interesting? It's when we drew that y equals 2x, it started down and ends up. So I'm going to face this wall because I think it's easier for you guys to see that when it does that, it starts down and then we end up. So why don't you guys do that with your arms, just so you could see. Yeah, it's kind of like we're flying a little bit. But no matter what happens in the middle, even though this is for the negative though, so I'll show that example when we do negative. But it starts down and ends, starts down and ends up. Perfect. And now for our negative, that's this example we drew here. We notice it starts up and ends down, like that. So even though for the x cubed, negative x cubed, there's a little curve in it, that doesn't really matter, right? Because it's still, the arrows at the end are going to stay the same. Now just to show you guys that this is true for anything, I have this nice graphing calculator online here, and we're going to fill it in with some value. So someone can give me a function. It could be anything. It could be, so we already did these ones over on your charts here, so let's not do one of these, but it could be something like to the 7th or to the 6th, just to see what happens, to see if this is actually true, what we said. And you could put whatever coefficient you want.
Can we have 2 to the 7th?
2 to the 7th? Y equals 2 to the 7th. Let's see what happens. 2x to the 7th. And let's see what happens to our graph. Well, look at that. It should, let's look at our charts, and we see that it should start down and end up. And it seems to do that right here. Can everyone see it?
Yeah.
It's down and then it ends up. Wow, let's try something different. Who else wants to give? Maybe an even one?
Negative x to the 6th.
Negative x to the 6th. That sounds cool. And look at that. It's just down like we had with arms before. They're both down. So it's true that no matter what power you have it to, the degree of the function, the highest power, it's always going to follow whatever the degree of the function is. So it doesn't even matter if I made this negative 6, like minus 15x. It still doesn't matter. See how it's still going to end down? So it doesn't matter what else you have on the chart, it'll still be there. So it still works out. So that's all we have to remember. And if we keep this chart with us and we just practice that at night when we go home today, then I'm sure we're going to remember it for tomorrow, and then we'll always know. And we can always use our arms as our nice little guide for us, right?
Yeah.